Hi, Hybrid. Thank you guys so much for taking care of everything when I wasn't here yesterday. I was so happy that I got some good reports on you guys. So before we start our formative today, I do want to do a brief review so that way you feel comfortable for the formative. I know this is a topic that I wasn't here for, so I want to make sure that we're good. So if you pause the video, you can take a few minutes to try the problems that you see on the warm-up. Okay, so it says write a linear equation in function notation for the tables below. So the first thing we need to do is we need to know the slope and we need to know the y-intercept. So I'm going to say m equals and b equals for the first one. So remember, slope is the change in the y divided by the change in the x. So if you need to, you can always label this as pick any 2 points. I'm just going to pick the first 2 points. This is my first x. This is my second x. This is my first y. This is my second y. From there, you can do y2 minus y1 divided by x2 minus x1. Or you can just figure out what's happening every time. So I noticed that in the first one, the x's, they seem to be going up by 2. And the y's seem to be going down by 25. So again, if we do change in y divided by change in x, that means negative 25 divided by 2, which is negative 12.5. That's my slope. Okay. My y-intercept is easy to find. So you look for when x equals 0, what is our y? In this case, it's right on our table and we see that it's 150. Okay, so now I can put it into y equals mx plus b, but what makes function notation different than when we write our regular equations is we have to have f of x. So f of x equals negative 12.5 x plus 150. And that's our first one. All right, if you're looking at the second one, we're going to do the same thing. Let's find the slope and find the y-intercept. Okay, well, looking at my change in my x's, it looks like it is adding 2 every time. If I look at my change in my y's, it looks like we're adding 5 every time. So change in y divided by change in x would be 5 over 2, or 2.5. Now the y-intercept is a little bit different because if you notice, we don't have a 0 in the x row. So what we can do is we can kind of work backwards. So if I was working backwards, if I start at 4, and if I'm moving to the right, I'm adding 2. That means if I move to the left, I have to subtract 2. So that would take me back to 2. And if I take away 2 more, I get 2, 0. Okay. I'm going to go the same on the bottom, but the bottom rule is adding 5 moving to the right. So that means I have to subtract 5 going to the left. So if I go 1 jump, I would be at 10. So 210 would be that pair. And if I go back 5 more, then I would be at 5, 0. So right here, 0, 5 is my y-intercept. So 5. And again, we can write it in function notation. I can say f of x equals 2.5 x plus 5. So it's just like y equals mx plus b, but instead of y equals, we replace it with f of x. Okay, so then the bottom part of the warm-up has you guys graphing the 2 equations that we have in the top. So looking at the first one, my y-intercept is 150, so I can put my dot at 150 on the y-axis. And I'm going down 12.5 and over 1. Okay. So for this one, I can go down roughly where 12.5 would be. It looks like we're counting by 25s. So if I go roughly down 25 over 1, or sorry, 12.5, I'm going to keep on doing that. It's not going to be pretty because we're not counting by whole numbers, but we're going to see something like this. So this is what our graph would look like. Okay. For the next one, our y-intercept is 5. So I'm going to start at 5 on the y-axis. And I'm going up 2.5 and to the right 1. Okay. So I'm gonna go, if I'm counting by fives every block, up 2.5 over 1, up 2.5 over 1. Again, it's not pretty. And you guys know how this board does not like to graph nicely, so it's gonna look something like that. Okay, if we had better slopes, it would probably look a little bit better. Okay, all right, let's look at the next one. For these ones, we're going to determine whether each one of these and the different representations is a function or is not a function. So remember, the rule for function is it has to have no repeating x's. Okay, so we're going to look at our x values and determine if there are repeats. So go ahead and pause the video and see if you guys can figure out if these ones are functions or not. Okay, so if we look at the first table, I'm looking just at the x values. So I'm looking right here, and it looks like every one of them are unique. None of those repeat. So yes, this is a function. If I'm looking at my map diagram, the circle or oval on the left is my x and the right is my y. So the left one is the one I'm looking at. And if I'm looking at this, all of them go to their own y except for number 9. -9 is going to -16 and -9 is going to 9. So if you wanted to, if you weren't sure about those, remember you can always write them out as ordered pairs. You would see -9 comma -16 and -9 comma 9 have the same x value. So this one is not a function. All right, the graph on the right is a circle. If I do the vertical line test, so I draw a vertical line anywhere on my graph, I see that it hits 2 times. It is only allowed to touch once. So there are 2 x values. If that was a straight line, you would see the 2 x values that are the same. So that is no. All right, let's look at the bottom 2. So again, I'm only looking at the x value, which is my first number in the ordered pairs. And it does appear that every single one of them are unique. There are no repeats. So this is also a yes. And lastly, I have a discrete graph with dots. And again, if I draw a vertical line, that one only hits 1 point. If I slide it to the right, 1 point, 1 point, 1 point, 1 point, and finally 1 point. There's nowhere where I'm going to put the vertical line where it's going to hit 2 points or more. Okay, we can only hit 1 point and have the same x value. So that one is also a function. Yes. Okay, so when you're talking about function or not, there's different things you can say. You could say there are no repeating x values. Every x value has their own y value. You can say it passes the vertical line test, or it doesn't pass the vertical line test if it's not a function. The next part is evaluating functions. So in this case, they give us the function and function notation, and then they tell us what to substitute in for x. So in this one here, they say f of x equals 4x plus 1, and they say find f of 3. So you notice the 3 is in the x spot. So that means I'm going to replace the x with 3. So every time I saw an x, I replaced it with 3. The f of 3 that's on the left-hand side will just come down. That is just the name of the function. Right? It's function when x is 3. The right side, I'm going to go ahead and solve. 4 times 3 is 12. 12 plus 1 is 13. So therefore, f of 3 equals 13. Okay. See if you can go ahead and pause and try the second one on your own. All right, this is a different function, h of x. They just changed the letters in the front so that way you see different functions. In this one, we're going to replace our h with -9. Okay. Again, h of -9 is just the name of the function. And then I can go ahead and multiply on the right. So 4 times -9 is -36. And -36 minus 2 gives me -38. All right, watch out on the next one. This was the caution that I talked about in the notes yesterday. This one is not asking you to evaluate when X is 0, okay? You notice here, the 0 is not inside the parentheses, it's on its own. So that means that the entire g of x side is going to become 0. So when I rewrite this, the g of x side is going to become 0, and then I'm going to put 2x minus 6 on the right. So this time I'm solving for x, not g of 0, if that makes sense. Okay, so this is not g of 0. Okay, it is g of x equals 0. So in this case, I would just solve it like a two-step equation. I'm going to add 6 to both sides. So 6 equals 2x. And then I'm going to divide by 2. So x equals 3. Okay, there is a big difference between the top two and that bottom one. Watch out, because there are quite a few of those on your summative when you take it. Okay, the next thing I want to focus on is I want to focus on word problems. So let's go ahead and look at the next one. Billy's Rocking Gym charges a one-time fee of $35 and charges a $25 fee for every month. Use the variable X for numbers of months and determine how much it would cost for the membership at Billy's for 7 months. And we want to write it in function notation. So the first thing I want to do is I want to identify that X is months. Okay. And my f of x, or my y in this case, if it was y equals mx plus b, is going to represent the total cost of the membership. Okay, so that's important to know. So think about this. If we were writing it in slope-intercept form, what is my rate? Okay, so I'm looking at the numbers. I see 35, so I'm going to circle that. And I'm going to circle 25. And then I see for every month. For every is the rate. So that's like saying each month. Okay, and that means I need to multiply. So that is going to be my slope. And that one-time fee of 35 is going to be my y-intercept. So when I write it in function notation, I should have f of x equals 25 per month, 25x, plus the $35. Now that I have it written, now I have to evaluate for what they wanted. So they said for 7 months, we want to figure out how much this is going to be. So basically they're asking me to find f of 7. So I'm going to replace my x with 7, and we're going to solve. Okay, in this case, 25 times 7 is 175, and 175 plus 35 gives me 210. Okay, so therefore, f of 7 equals 210. Okay, now when we have word problems, we want sentence answers. So I'm not going to write it up here, but looking at the question, it says, how much would it cost to have a membership at Billy's for 7 months? So I can reword that, and I can say it would cost $210 for a membership at Billy's for 7 months, because we're talking about money here. So function notation, although it looks scary, is just slope-intercept form, just in a different format. Okay. Martha goes to an amusement park with her friends. Entry to the park costs $15, and each ride costs an additional $3 for each person to ride. If Martha and her friends plan to ride 12 rides, how much money should she tell her friends to bring? Create an equation in function notation and determine how much each of her friends should bring. Use R to represent the number of rides. Okay, so in this case, we're going to say R, or if you want to, you can use X, it doesn't matter. But since they said R, we're going to say R's rides. Sometimes they like switching up the variables. Okay, so then that means that f of R instead of f of X would represent the total cost as well. So go ahead and pause the video and see if you guys can write the initial function notation and then evaluate for if the friends plan to ride 12 rides. Okay, so I'm going to say f of R equals. So I see in the problem that it costs $15 just to get in the park. So that is my one-time fee to get in. And means that we're going to add it costs an additional $3 for each person. So that is going to be my rate, my $3 per person. So I would say $3, whoops. $3 per person. Or per ride, and then plus the $15. Okay. All right, so let's look at this. Let's see. If I go ahead and I substitute the 12 in. Okay, and if I'm looking at 3 times 12 is 36. And if I add those together, I get 51. So f of 12 equals 51. So therefore, if Martha and her friends plan to come to the park and they plan on riding 12 rides, each of her friends should bring $51. And that would be the sentence that you would write. All right, let's look at the next one. Dan is supposed to order pizza for his class at school. He plans to buy 4 pizzas. Use the variable P to describe the number of pizza Dan buys. There is a $3.75 delivery charge and $7.50 charge plus $8.25 tax per pizza. How much should Dan plan on paying for this order? All right, this one's gonna be a little different because we have that tax in there too. So go ahead and pause and see if you guys have any ideas of what you might write for your function notation. All right, so I'm gonna say P equals pizzas because that's what they told me to use. And really it's number of pizzas. Okay, number of pizzas. And again, like most of the other ones we have, F of P is gonna be the total cost of the pizzas. Okay. So in this one, we have a lot of numbers. He plans on buying 4 pizzas. So that's going to be what we're evaluating. So what we're substituting in the end. But as far as the equation goes, there's a $3.75 delivery charge. There's a $7.50 charge plus $8.25 tax per pizza. Now, I do believe that the $7.50 and the $8.25 are both connected in this one, so they are both per pizza. Okay, the $3.75 delivery charge is the one-time fee. You only have to pay that once. It's not for every pizza that you buy. So what we're going to do first is we're going to have F of P. All right, we have a $7.50 charge per pizza. So we'll say P, $7.50P. Plus, we have an 8.25% tax per pizza. We have to turn that 8.25 into a decimal. So to do that, we take our decimal point and we move it 2 spaces to the left. So I would write that as 0.0825p. Okay. And then I have that one-time fee of $3.75. Okay. So now we need to evaluate for F of 4. So F of 4. So I'm going to go ahead and substitute this in real quick. You could combine like terms if you wanted to first. That is totally up to you. Okay, so if you wanted to combine those two into one, that is fine. If you do combine them, it ends up being 7.5825 times 4, which in the final answer is going to be $30.33. That's for the cost of the pizza and the tax. Plus, we have our $3.75. So if I combine them together to see what F of 4 equals, let me go ahead and do the math real quick on my calculator. 1 second. Just double checking that one line before to make sure everything is good. So I'm just pulling this over real quick so we can double check. Actually, I'm just gonna pull it over here because it's not gonna let me do that. But if I have, let me see, 750 times 4 plus, sorry, it was 0.8. I'm missing the 2.5 there. Times 4. That does equal $30.33. Plus I have to add my 375. So I get 3408. So that would be the total cost. So let's think about what we can rephrase this. If Dan plans on buying 4 pizzas, he will pay $34.08. That's pretty cheap for 4 pizzas. Okay, luckily for you guys, there will not be one like this on your formative or your summative with the percents, but I did want to show you one just in case on MCAP you happen to see one with the percents. Just know that tax and the charge of the pizza are the per pizza. All right, let's see this one. There are 17 people playing laser tag. 2 people get out per minute. Use the variable M for number of minutes and tell how many people were remaining after 6 minutes. So they say M is equal to minutes. And so that therefore F of M will be the total remaining people in the game. Remaining in the laser tag. All right, go ahead and pause the video and see if you can try this one. Okay, so this one is a little bit different. We have 17 people playing total. There are 2 people getting out per minute. So per means to multiply. So that tells me that 2 is my rate. Okay. And this one, I'm starting with 17 people. And if people are getting out of the laser tag game, that means that my number is decreasing. So when I write my function notation, I'm going to start with 17 and I'm taking away 2 people per minute. Okay, so now we have to figure out how many will be remaining after 6 minutes. So F of 6 is 17 minus 2 times 6. Well, 2 times 6 is 12. 17 minus 12 gives us F of 6 is equal to 5. So we can say after 6 minutes, there will be 5 people remaining in the laser tag game. So be on the lookout for those keywords that tell you whether to add, subtract, multiply, or divide. Okay. I believe this is the last word problem that I have before you guys can try the formative. Stefan earns $8 per hour and $10 per overtime hour worked at Jacoby's Fun Park. Use the variable H and O to represent the number of hours worked and the amount of overtime hours worked. If on Friday, Stefan works 9 hours and 2 extra hours, how much money will he earn? So this again is another unique one. So this one I'll work through with you. We have 2 variables this time. So it says that H stands for the number of hours worked. And that is his standard hours that he worked, his regular time. They say O is going to be overtime hours. Or overtime hours worked. Okay. So in this case, we're trying to find a combination of both. So I'm going to say H and O together. So F of H and O. Again, you don't see this too often, but it is possible that you may have two separate variables. And the reason why we have two separate variables is usually the overtime rate is higher than your regular hours. And we see that in the numbers here. It's $8 per hour for regular time, and it's $10 per hour for overtime. So remember, per means to multiply. So those are our two rates. Okay. So when it comes to his time worked, it's going to be $8 per hour regular time plus $10 for his overtime. All right, and I know I'm gonna make that a different color. It's a little hard to see. I don't want that to look like 100. We'll make it an O for overtime. Okay, so now all we have to do is substitute 9 in for H and 2 in for our O. I'm just putting 9 plus 2 there. This does not really mean 9 plus 2. Okay, it just represents the two things there. We've got 8 hours times 9 hours that was worked, plus 10 hours, 2 hours worked, $10 an hour. So for the regular time, he works 9 hours, he makes $8 an hour. That means he earns $72 of normal pay. Plus, he worked 2 hours of overtime at $10 an hour, so that's another $20 he earned. So he earned, I would say F of, I'm just gonna say H plus O, because it doesn't look right when you say 9 plus 2. He earned a total of $92. Okay, so again, our sentence, how much money will Stefan earn? If he works 9 hours and 2 hours extra hours, he will earn $92. Okay, so now you're going to take your formative. So here are my expectations as usual. You may use a calculator. Please show your work whenever possible. Demonstrate academic honesty and try your best. Okay, if you get done, I am not there for the missing assignments, but you can finish anything from this week that you did not finish. And then if you get done early, I trust you guys enough to work on IXL. Just make sure that you plug your computers back when you're done. Okay, let me look at this formative real quick and see if there's any other notes that I would like to tell you guys. Yes. So make sure when you are writing your domain and your range that you are writing them in order from least to greatest, and you are not repeating numbers when you're writing your domain and your range list. And I think that's it. So if you have any questions, you can email me through Schoology and I will try to answer them for you. There is a worksheet on functions and not functions that you can finish if you get done your formative as well. Okay, have a great day and I will see you tomorrow.